Hello friends, welcome back to my YouTube channel. So it's a day 2 of graph tutorial. So yesterday I discussed about DFS that go deep in algorithm like for example this grid. As I discussed before, like let's say this is island, okay, this orange is island. Then we have to go deep into deep until a non-island that is zero not come, okay. So that is DFS. I discussed before, like I discussed with the help of number of distinct island. So today's I'm going to in today I'm going to discuss about another common algorithm, graph algorithm, that is BFS, breadth first search. So as the name says, we have to take breadth by breadth, like level by level, and like let's see this whiteboard, okay. So this is a point, okay. So first we have to go this there is so many levels, like okay, okay. So level 1, then level 2, level 3. So in breadth first search we have to go level by level. So first I can explore all. Let's suppose there are oranges in this level, this orange or something element, okay, that we have to explore. So orange is everywhere in every level. So we have to go to, this is the origin, okay, this black one. So the first level we have to explore these many oranges. We have to explore the first level oranges, all the oranges that is available in first level. Then we go to second level, then we go to third level. In this way breadth first BFS works, okay. So let's see today's question, that is pretty related to this orange problem. That's why I took orange example for this level. So let's see the question. So the question is rotting oranges. So let's see the question, that is, in a given grid each cell can have one of the three values. So there are three values, okay. 0 representing empty cell, 1 representing fresh orange, 2 representing rotten orange. So there are three types of cell. One is empty cell, then one is for fresh orange, and one is for rotten orange. So every minute, any fresh orange that is adjacent, like 4 directionally to a rotten orange, becomes rotten. So every minute, so this every minute makes this question breadth first search. Return the minimum number of minutes that must be elapsed until no cell has a fresh orange. So every minute, so we have to take minute by minute, like at first minute, suppose at 0 minute, suppose this is a rotten orange and all of the others are fresh orange, okay. So at first, uh, in minute 1, it can rotten only adjacent value. So you see the level. So in minute 1, it it is going only to level 1, like this is level 1, and rotten this orange. Then in minute 2 we have to go level 2, that is now. Now these many orange, that 3 orange is already rotten. So this orange can rotten this orange, this fresh orange, and this orange can rotten in this orange, this fresh orange, in the minute 2. That is there. This is level 2. So in level 3 this orange is going to rotten this fresh orange. So there is it, there it is. And in the minute 4 this orange is rotting this fresh orange. So in minute 4 we have seen that all oranges are rotten now, so we have to return 4, okay. So this is it. So let's, and -1, like okay, let's see this example. Why the answer is -1 for this problem. So this is the question where two is the rotten orange and one is the fresh orange. Okay, so at minute 1 it becomes it rotten the adjacent value, like the adjacent of 2 is 1, so we go to level 1. So this is level 1, then it becomes rotten. Okay, so now level is equal to 1, and now these two oranges are rotten now. Then this rotten orange makes his as adjacent to rotten. Okay, like this is adjacent to this fresh orange and this is also adjacent to this fresh orange. So for level 2 we can easily take this to this rotten. So now at level 2, so level or minute it is equivalent. Okay, so now at level 3 we have to take this to rotten orange. Okay, so now we are in level 3. Now at level 4 we have to rot this orange. So now this. Okay, so at level 4 until we find any fresh orange, so we can go to that orange. Okay, but we cannot go to any empty cell that is there, so we cannot reach out this fresh orange. So this orange is going to be fresh forever. We are not going to rotten this orange, because we are this orange is unreachable to this rotten oranges. So that's why the output is -1. So now you understand this. So for BFS we have to use Q. So let's see the algorithm first, then I can explain more about it. So Q, I'm taking Q for taking care of the coordinates, like what is the current coordinate. Okay, like coordinate of 2. Whenever I find rotten oranges, I have to give it to the level current level, so the coordinate of that rotten oranges for taking care of. So now count is equal to 0. Count is basically the number of fresh oranges for for cases like this, because every if at last at the end of the program, if number of rotten orange is not equal to number of fresh orange at first, then we can assume that this this rotten orange are not reachable. This one of the fresh oranges or more fresh oranges are not reachable to any of the rotten oranges. So yeah, that's it. Now we have to go to matrix. So as I said, if we find any fresh orange, then we have to increment our count for solving this edge case, like -1. So let's do that. if there is a rotten orange, then we just have to push it to the queue. Okay, like at first level, like the size of queue at each level is the size of that level. Like at first the size of queue is 1, and we are pushing this orange to our queue. Then at level 2 we are pushing these two oranges to our queue. Then at level 3 I'm pushing these two orange, like this one and this one, to the queue. And at last and in the third one I'm pushing this orange, and at the end I'm pushing this. So this is it. So let's see. So while queue is not empty, like there are rotten oranges, right? Because queue is comprises of rotten oranges. Then size of queue is equal to q dot size. Then let's say current time is equal to 0 at first, because current time is equal to 0. Okay. Also, if int and result is equal to 0, this is the total time taken. So current time is like the current time, like current minute. If in this level I am going to rotten any orange, then we have to increment our current time to 1. And later after this level I can add this to my answer. So yeah. Shit, man. While size minus minus, like we have to explore every rotten orange of the current level. So the current coordinates are I and j, let's say. So current coordinate is for q dot front dot first, then j is equal to q dot front dot second. This is it. Now q dot pop, because we have to pop our q. So let's see the adjacent sides of adjacent fresh oranges of this particular rotten orange. Okay. Then we have to decrement our count, because this fresh orange is going to rot. Then we have to make this fresh orange to rotten orange, just like in DFS, that is we are making island to water in previous day, last day. Then current time is equal to 1, and at last we have to push it for another level. Now we can do we have to do same for every adjacent side. Okay. Oh, sorry about it. No, I was confused little bit. So we have explored all the four vertices, all four sides. So now we have checked my current level. So at last we have to add this current time to our result. Like we have to calculate total time, right? So this is the total time. And at last we just have to first check is count is equal to 0, like all fresh orange become rot orange or not. If so, then we just have to return result. If not, then we just have to return -1. So I think this should work. Yeah. So hope you like this video. Like, okay, something is wrong. 02. Okay. Result is equal to 0. Something is wrong. Okay. I don't know what's wrong with this. Okay. So now it is, I think. Yeah. So hope you like this video and hope you understand the difference between BFS and DFS using both of the problem, that is number of distinct island and rotten oranges. Like in rotten oranges we see that we are going only adjacent one, not the whole island, like not the whole oranges. But in the in case of number of distinct island, we have to go to whole island, you know. So you see the difference. Okay, so this is the difference between breadth first search and depth first search. So this is the difference. So hope you like this video. Comment, like and subscribe if you find this video helpful. I'll be back tomorrow with a new question of graph with a new algorithm, or we can practice DFS or BFS for 1 or 2 days more to make you comfortable with these two algorithms. So these are the skeleton of graph algorithms. Okay, so you have to understand these two algorithms very nicely for mastering graph algorithms. So yeah, that is it for today. Thank you. Bye.